Hello everyone. In this video I will explain to you the similarity between two polygons and we will practice specifically about the right triangle or any triangle. So if we have two triangles and they are similar, we say about these two triangles that they are similar if the corresponding angles are equal in measure, but the ratio between corresponding sides, the ratios are equal. So for example, if this is 3 and this side is 6, and you are given that the two triangles are similar, this is x and this is, for example, 8. To find the value of x here, you should use the similarity feature, which is the ratio between corresponding sides. The ratios are equal. So 3 over 6, because 3 and 6 are corresponding sides, is the same as x over 8. And here you can do this by cross multiply the two fractions. So 3 times 8 divided by 6, which is 4. Now we can use the same property to solve many problems. For example, if you have the two polygons here or trapezium are similar, 5, and this is for example this is 3, and we have here for example 4, and this is x. How to find x? Here we do the same. X over 4 is the same as 3 over 5, and we do cross multiplication, which is 3 times 4 over 5 by the calculator. Now let's go to the triangles. The two bases are parallel. We have two triangles, this one, the small one, and the big one. We have two triangles and the two triangles are similar. This angle is equal to this angle, and the same here because they are corresponding. So if this is x, y, and this is a, b, we can say that a over b is the same as x over y. So if you were given this is 3 and this is 9, a is 2, and he is asking about b, we can divide corresponding sides. X over y, so it's 3 over 9 equal 2 over b, and do cross multiplication, so b equals 2 times 9 over 3. To make sure that you understand, let's try this one. X over 8, 3, or 6 over 12. So now to find x, so it's part over part. We divide the big triangle in two parts. X over 8 is the same as 6 over 12. So x equals 6 times 8 over 12, which is 4. But we have a different type of, or a different property of similar triangles. What if we are dealing with the base, for example xy, and this is a, b, c, d. If the question is involving with the base, any of the two bases, so here we don't take a over b, we take a over all of this, the big side, a plus b, and c over c plus d, and x over y. For example, and don't think it's too hard, it's very easy. 3 over 5, and this is x over 12. If the question is about one of the two bases here, to solve this, it's x over 12, and this is the big side over the big side, okay? Or the total side of the small triangle with the total side of the big triangle. Now we take the small triangle 3 and the big triangle, which is 8, and we do cross multiplication. 12 multiplied 3 over 8. Okay, the same idea if we have with a different example, different idea here. To find this question mark, it's a part over 15. You divided this in a question mark and 15, so you should divide this in 8 and the rest of 18, which is 10, because 18 for the whole side, and we took 8 from this side, we still have 10 here, and you do cross multiplication. Now let's go to the Euclidean theorem. Euclidean theorem, if we have right triangle in this angle and we have a altitude of the triangle, and you were given 9 and 16, and I'm asking about x or y or z. You have only two givens, and I'm asking about 3 sides. Okay, to find the value of each of the missing sides, now you need to get the base of the triangle. So first of all, the solution will be in this color. Now we know the length of the base. So now to find x, we take the root. To find y, z, we take the root, and y is the root. To find x, take the nearest part of the base, which is 9. It's multiplied by the whole base, which is 25. To find z, because I'm putting them in a different order. To find z, take the nearest part of the base, which is 16, and multiply it by 25. Last one, to find y. The y is dividing the base in two parts, 9 and 16, and we take 9 and 16 to find the answer. And this is everything about Euclidean theorem. Of course, we have a different examples, and we can do different one. For example, here the base is 100, and for example, this is 36. It's not drawn to scale, so it's okay. 36, and we are asking about x or y. So to find x, this part is 36 multiply the base, 100. To find y, this part from the 100 is 64, so y equal 64 multiply 100. Okay. Okay. If you have, for example, 6, 8, and this is 10, for example, and we need to find x. When you think by this way, you cannot find the value of x, because x is the root of this part with this part, but here we don't have. So we have a different rule to find x here. The rule here is to multiply 6 and 8 and divide this by 10. And this is everything about similarity that we are discussing or studied in the class.